The moon, our closest celestial neighbor, has captivated humanity for millennia. Its soft glow illuminates our night sky, inspiring countless myths, legends, and scientific inquiries. But the moon is far more than just a beautiful object in the sky. It plays a crucial role in shaping life on Earth, influencing everything from tides to our planet's very stability. For centuries, humans have gazed up at the moon, wondering about its origins, its composition, and its influence on our world. Ancient civilizations tracked its movements, developing intricate lunar calendars to guide their agricultural practices and religious ceremonies. Today, thanks to advances in science and technology, we have a deeper understanding of our celestial companion than ever before. We've sent probes to orbit it, rovers to explore its surface, and even astronauts to walk upon its dusty terrain. Yet despite all that we've learned, the moon continues to hold mysteries that beckon us to explore further, to unravel the secrets it holds within its cratered surface and ancient history. One of the most captivating features of the moon is its ever-changing appearance as it cycles through its phases. These phases, from the new moon's invisibility to the full moon's brilliant glow, are not random occurrences. They are a celestial ballet choreographed by the interplay of sunlight, the moon's position in its orbit around Earth, and our own perspective from Earth. The key to understanding the moon's phases is to remember that the moon doesn't emit its own light. Instead, it reflects light from the sun. As the moon orbits our planet, the angle at which the sun's light strikes the lunar surface, and the amount of that illuminated surface visible from Earth, changes constantly. This dance of light and shadow creates the familiar cycle of lunar phases: the waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, and finally, back to the new moon, where the cycle begins anew. Each phase, a unique and beautiful stage in the moon's monthly journey around our planet. The moon's influence extends beyond its illumination of our night sky. It exerts a powerful gravitational pull on Earth, a force responsible for the ebb and flow of our planet's oceans, the phenomenon we know as tides. Gravity, as we know, is the force of attraction between objects with mass. The moon's gravity tugs on Earth, and more specifically on the water that covers a large portion of our planet's surface. This pull is strongest on the side of Earth facing the moon, causing the water to bulge outward, creating a high tide. On the opposite side of Earth, the moon's gravitational pull is weaker. This difference in gravitational force causes another bulge of water to form, creating a second high tide. As Earth rotates, different locations on our planet pass through these tidal bulges, experiencing the rhythmic rise and fall of sea levels. Section 4. A silent world. The moon's lack of atmosphere. Unlike Earth, with its life-sustaining atmosphere, the moon is an airless world, a silent, stark landscape devoid of the protective blanket of gases that we often take for granted. This lack of atmosphere has profound implications for the lunar environment and for our understanding of its history. Without an atmosphere to scatter sunlight and create a blue sky, the lunar sky appears black, even during the day. Stars are constantly visible, undimmed by the scattering effects of air molecules. The absence of an atmosphere also means there's no air resistance, so objects fall at the same rate regardless of their shape or mass. The lack of an atmosphere also leaves the moon's surface exposed to the harsh conditions of space. Micrometeoroids, tiny particles of space debris, constantly bombard the lunar surface, creating a fine dust called regolith. The temperature on the moon fluctuates wildly between extreme heat during the day and frigid cold at night, a consequence of having no atmosphere to regulate temperature. Section 5. Birth of a Moon, the Giant Impact Hypothesis. The question of how the moon came to be has intrigued scientists for centuries. Today, the leading theory explaining the moon's formation is the Giant Impact Hypothesis, a dramatic tale of cosmic collision that paints a vivid picture of the early solar system. This hypothesis proposes that billions of years ago, when the solar system was still in its infancy, a Mars-sized object, often called Theia, collided with the young Earth. This impact was cataclysmic, ejecting a massive amount of debris into space. Over time, this debris, bound by gravity, coalesced, gradually forming the moon we know today. Evidence supporting the giant impact hypothesis comes from various sources, including the moon's composition, which is remarkably similar to Earth's mantle, and the moon's relatively small iron core, suggesting it formed from the outer layers of the colliding bodies.